Hello. Today we're going to be looking at the unit circle and the sine and cosine graphs to get a better understanding of these. So, if we look here, our unit circle is something that's very unique. Our unit circle is going to be just our normal x and y axis, and we'll have our circle on it. I'm going to try and even this out. Looks good. Okay, so we have our x-axis and we have our y-axis. And we're going to be looking at some key points here. So there's a point here, 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 and here. And the key thing with the unit circle is that the radius is always 1. So if the radius is always 1, if we were to draw a line from here to here, we would just be at point 1, 0. If we were to draw a line from here to here with a radius of 1, we are now at point 0, 1. This would be negative 1, 0. And this would be 0, negative 1. So the key thing is looking at this is that with a unit circle, always has a radius of 1. Okay. When we're using our Ferris wheels, we had different radiuses, so those wouldn't technically be unit circles, but we're using this unit circle as a basis, and like I said, the unit circle always has a radius of 1. And what we're going to do is we're going to use this radius of 1 and look at our different triangles here. So for instance, we have a triangle like that. We could make a triangle here. There's lots of different right triangles that are made from our circles, as we've been seeing with those Ferris wheel problems. Okay, the big thing to remember though is that since this is a unit circle, these all have radiuses of 1. Okay, now our angles are going to be different, obviously, because we're at different points on this triangle. And so when we're looking at this, we're going to be looking at our angles and how those relate to a unit circle and what that does to our graphs for cosine, sine, and those ones that we've been dealing with. Okay, so like I said, the unit circle always has a radius of 1, so that's going to be our basis. And then we're going to be taking a look at what those graphs are going to be. So I'm going to copy this. And we're going to take a look here. At our unit circle. So let me redraw my axes. Oops, it's not very straight. And I'll move that one down. There we go. All right, so let me copy this here. Okay, so with sine of theta, we are looking at what we're going to call the height of our triangle. And that's what we're measuring. Okay, so when we're looking at sine, we're measuring the height. So when we have something like this, like that triangle there, we are measuring this length of it. That's what we're looking for when we're looking at sine. We're looking at the height of that triangle. And so we can make an infinite amount of triangles within this circle that all have different heights. So I could make another triangle that goes to here, another triangle that goes here. We're basically going to be able to make any amount of right triangles within this circle that we can measure the height of. The key thing to remember, though, is that when we're looking at these circles, there's only 360 degrees in here. So depending on what our angle is, we're going to start to see some things that go on there. And so if we look, we have key angles right here. For instance, at 0, 1, we have a height of 1. That's at 90 degrees. This is at 180 degrees. This is at 270 degrees. And this one here is at 0 degrees or 360, depending on if we've made one full rotation or not. So these are our key points and their degrees. And so we're going to look at these degrees and say, okay, let's use these as our key points, and then we can fill in the middle stuff if we need to later. So with sine, we're measuring how tall something is, or the height of that triangle. So when we look at our graph, we're going to have a maximum of 1 and a minimum of -1. Okay? And we're going to have 0 degrees here. And we'll say we'll go out to 360 degrees here. Since we're not looking at a particular problem, we're not using time, we're just going to be measuring this based on degrees and the height. And so if we look at that, then we would have 720 degrees here, or another full rotation. And within 360 degrees, we're going to break that up into 90, 180, 270, 90, 180, 270. And then this would be 540, 450, and then 630. And this doesn't look very spaced out very well, so let me redo this one so it looks more like a quarter. That looks better. And so what we're going to say is, well, how tall is our triangle at these key points? So at 0 degrees, we can see that our triangle, I'm going to do this in a very different color here. I'll choose this light purple. At 0 degrees, my triangle has no height. At 90 degrees, my triangle now has a height of 1. At 180 degrees, I have no height again. And at 270 degrees, I have a height of -1. And then at 360, we come back to the end and we get to here. And so what we see is this graph starts with a height of 0. At 90 degrees, we hit our maximum of 1. At 180 degrees, we're back at 0. Then we go to 270 at -1, and then at 360. Well, what's going to happen is this circle is going to continue to rotate. So what we end up getting is our graph starts all over again. I'm going to switch these here so that it looks a little bit better. And it just repeats itself again and again and again. Now there's a couple key things that we're going to look here. First thing is going to be called the period length, and the other is going to be the amplitude. Okay, and the period is just how long it takes for one cycle. And the amplitude is really just the min and maximum values above the midline. And another way we could just say simply that this is the radius. Okay, so our period length is from 0 to 360. That's one full cycle, because then it starts to restart itself, okay? Then we would have another cycle here. So that would be 2 full cycles, or 2 periods that go there. Then we want to look at the amplitude, or its height. And so the amplitude of this is going to be, oops, let me choose orange, essentially 1. That has an amplitude of 1. This has an amplitude of -1. So what we could say is that our amplitude on here has a value of 1, because it goes up 1 or down 1 either direction, and that's its peak. And that continues on and on and on. So we're looking at the period and the amplitude and of sine. And remember, sine is measuring the height of our circle, or I mean the height of our triangle within our circle. And the circle will just keep on repeating itself over and over and over again. And so that's our sine values for it, for the unit circle. And again, if our radius was to change, then our amplitude would change. If we were to speed up how fast this goes using like a different thing, then our period length would change as well. But for the unit circle, we're just looking from 0 to 360 and then repeating that over and over again to get the basics down. Okay, so let's take a look here at, let me re-copy this. And inside here, I'm going to get rid of all this. Okay, so now we're going to look at cosine. And our cosine of theta is really measuring the base. Of our triangle. And so what I mean by that is it's going to be really tricky to see this, but if we were to draw some different triangles here, so for instance, if I had a point here on the circle, let's say a point here, a point here, and just do one more point here. Okay, the base is in reference to this part here. So to that green part, we would have that as our base. I'm going to make this a little smaller. Okay. On the purple one, our base is only to here. So you can see the bases are all on the x-axis, so it's really kind of hard to visualize it. But as you start to see these more and more, it'll start to become second nature. And so then here, this would be the base of the blue. And that would be the base of the orange. So we have lots of bases that are overlapping each other, so it's not as clear to seeing it as we can with the heights that were here. But we still have a value of 1 for our radius. So that value of 1 is still going to be the maximum or the minimum that we can get. And if we look at 0.10, we can see that the base here is just 1. And then the base will be -1 on the far end at 180 degrees. Our base is nothing at 90, and our base is nothing at 270 either, because the triangle, it's just a straight line up or down. So what we're going to look at here for our graph is that we would have our +1 here, our -1 here, because that's what our radius is, and so those are our mins and maximums. Then we're going to have one circle, 90, 180, 270. And I'll recopy those. Make it look like that. And again, this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360, and then we start to get the circle going again. Oops, that should have been 450. So let's see what the width does. So at 0 degrees, it says right here, at 0 degrees, our width is actually at 1. At 90 degrees on our circle, if you go up to here, our width is 0 because it's just a straight line up or down. There is no left or right width. When we get to 180, we're at -1 because, again, we're just using our x and y axes, so that's the point we'd be at. At 270, we're back at 0. And at 360, we're back at that 1 because our width is now 1. And so we see this graph here. We see this coming downwards, then to here, then to here, and then to here. And that graph is going to repeat itself again and again and again. So if we look at this, we see that a key thing here is that our period length is still 360 degrees, or 1 rotation. Our amplitude is still 1 because it goes above or below 1 and then comes back. That's where it peaks or it valleys. Its mins or maxes there. So our amplitude and our period length are still the same. So it's almost identical in those features to the sine. The only difference between sine and cosine, though, is that where we're starting. And because we're looking at the base, we're going to start here at 1. Because the base is equal to 1 there, where the height was actually 0. And then we start to make sure we're looking at that. So again, the key thing with cosine is to remember we're looking at the base length, not the height. So our graphs look very similar, but they start at different places and they're kind of shifted just a little bit. But the period and the amplitude are always the same as long as we're using the same circle. And in this case, we are with the unit circle. And that's what we're going to be looking at going forward. Now, on this particular day, we're just going to make sure we get these notes down and see what questions you have. I'm not going to put an assignment on this because it gets a little complex without knowing where you're at and what questions you have with the notes. On Thursday, we're going to do a few problems with this to kind of see what we're looking at. And again, we're using the unit circle as our kind of our anchor point. And then depending on what our radius does or how fast this is rotating, that's going to change our amplitude and our period. And that's what we're going to be looking at going forward. But we're just going to be focusing on sine and cosine. And today is all about just these notes. So if you have questions, please email me. I want to make sure we get this basic stuff down so that way we can kind of get into the other stuff as well. Like I said, please let me know. There's no assignment today. On Thursday, we'll have some practice. Today is just for you to questions, and I will put up a little link on our under this video to see for you guys to fill out questions that you have. All right. Have a good day.